So let's move on to the next question, guys. In this question, we are given that p is a positive odd integer and p is equals to sum of squares of two positive integers. Okay. And we have to compare the remainder when p is divided by 4 and 1, right? So one thing is very clear that p is odd, right? And p is the sum of squares of two positive integers. So let's assume x and y are two positive integers, right? So we can write p is equals to x square plus y square, right? I hope this should be fine. There should be no problem in this, right? So p is equals to x square plus y square. And we know that p is equals to odd, right? So this is odd. So odd is equals to x square plus y square, right? Okay, now I would like you to answer one question, that if we add two things and if we get odd as a result, what are the possibilities? The possibilities are either one is even, one is odd, or one is odd, one is even, right? Meaning if you add two odd things, the answer will be even. If you add two even things, the answer will be even. But if you add one odd and one even, then the answer will be odd. Okay. So one thing is very clear. Either x is odd, y is even, or y is odd and x is even, right? So this basically means one of either x or y is odd, right? Is odd and other is even, right? So one of them is odd, one of them is even. This is for sure, right? So for example, let's assume that x is odd, right? Let's assume that x is equals to odd. If x is equals to odd, we can write it in the form of, for example, 2k plus 1, right? Because what is 2k? 2k is an even number, because any number you multiply by 2, it becomes even. So that means 2k is an even number for any value of k, right? And if you add 1 to it, it will become odd. So whenever you have to represent any odd number, you do it by 2k plus 1, and whenever you have to represent any even number, you represent by 2k. Okay, so we have assumed that x is odd, so we can write x is equals to 2k plus 1, where k can be any constant, right? So now let's do one thing. Let's kind of add these things. So p is equals to 2k plus 1 square, right? So 2k plus 1 square plus y square, right? And what is y? Y is even, right? Y is even. For example, let's y is even, right? So firstly, we know that y is equals to even, right? Because what did I say? One of them is odd, one of them is even. So I assumed x is odd. So I can write x as 2k plus 1. And I assume the other one is even, obviously, if one is odd. So I can write y is equals to 2k, right? This should be fine. Now let's try and solve this. So p becomes x square. What is x? 2k plus 1. So 2k plus 1 square plus y square. So y square becomes 2k square. So if you solve this, this becomes 4k square plus 1 plus 4k plus 4k square, right? So if you take common over here, so you can take 4k square plus 4k square. So if you take, so this becomes 8k square plus 4k plus 1. So this becomes 4 times of 2k square plus k plus 1, right? This is p, right? Now we were asked in the question that what is the remainder when p is divided by 4. So if you divide this number by 4, if you divide this number by 4, so obviously this part is divisible by 4, because you can see 4 is over here. So if you divide this by 4, so 4 and 4 will cut. So this is absolutely divisible by 4. So what will be left? 1 will be left. right? So that means the remainder is 1, which means the remainder is equals to 1. So remainder is 1. So you get 1 as the remainder. You get 1 as the remainder. So since 1 and 1 are equal, so the answer is C. I hope this is clear. So what we did over here is that we knew that P is odd. So if P is odd, one of them has to be odd and the other has to be even. This is for sure. If one of them is odd, we can write it as 2k plus 1. If one of them is even, we can write it as 2k, just to represent even integer and odd integer. And now we just kind of calculate. So x is 2k plus 1, so 2k plus 1 square plus 2k square. We solve this, so we get this 4 times of this plus 1. So obviously this is divisible by 4 and 1 is left. That means 1 is the remainder. So this is 1, this is 1, so the answer is C. I hope this should be absolutely clear.